Hello, everyone, and welcome for today's session. Thank you all for joining. My name is Firas, and I'm the event planner for Microsoft Reactor in Redmond. Before we start, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary and please remain professional and on topic. This session is recorded. It will be available through Microsoft Reactor YouTube channel in about 24 to 48 hours. I'll be sharing the link to our YouTube channel in the chat. Plus, I'll also sharing a couple of links for our meetup page and our it slipped my mind. I apologize. Which brings us for our session today. This session will run approximately for 2 hours with time for questions within. Our speakers for today are Jim Bennett. He's a senior cloud advocate, and Sam Ronsky. He's a regional cloud advocate. Now I'm going to pass this to our speakers.
Awesome. Thank you very much, Firas. Thank you. And hello, everyone. Everyone's watching. And hello, Sam. How are you doing today?
Good. How are you? Good morning.
I'm good. I'm good. Yes, it is morning. It is morning. For those who joined us last week, we did an afternoon session. We're kind of alternating morning and afternoon. So yes, I must confess, last one, where being an afternoon session, I had the tea. Today, I'm a traitor to the cause, and I'm drinking coffee. What about you, Sam? What's your beverage of choice this morning?
I have two, actually. I have Jasmine Dragon Pearls. We were talking about those last time. And then I have Butterfly Pea Blossom, which you can't really tell on camera. It just looks black. But Butterfly Pea Blossom is not a tea so much. It's an herbal tea. But it brews to this really vibrant blue color. So if you're ever looking for something that's just like super wild and fancy, this one is that. And it also changes colors. It's sensitive to the pH level. So if you add any acid like juice, it will change to a purple. So
nice. Kind of a nice tea to have in like a clear cup. Make it blue. Squeeze a bit of lemon in there. Goes purple.
It's really cool with friends, cause especially if they don't think about it. If you just give them like a slice of lemon or something on the side and then they squeeze that in and the whole thing just changes as the lemon juice moves through the drink. It's super fun. So
nice. Because I guess it's not going to just suddenly just change, is it? It's going to, you're going to have swirls of purple coming through.
Yeah, have you seen like dropping paint or something into water? It's kind of like that. It happens relatively quickly. But it does have that little pluming like movement as the acid or whatever moves through it. It's pretty fun. It's really cool. Highly recommend.
Oh, I know it could be fun. Imagine taking like some lemon or some lemon juice, freezing it, then wrapping it in a bit of water and freeze that. It's got like an ice cube with lemon in the middle. And then you just drop that in the tea and it'll be blue. And then just over time, as it starts to melt, it will slowly turn purple.
I was actually looking at something like that over the weekend. Because there's been this whole thing where you can do like really cool things with ice and all this other stuff. So one of the things people do is they'll make like a mixed drink, and you will have whatever the base is, and then you'll put the other parts of it inside of the ice and have like the ice barrier, and you can actually like smash it with like a spoon or something, and it cracks and mixes as part of that, and then you just have like shattered ice to make your drink. It's pretty fun. I don't know, lots of cool ways to do things. Experiment.
Nice.
So
nice. So for those folks in our audience, we did raise this question actually last week and got some fantastic discussion about this. But if this is your first time on one of these sessions, tell us what tea you like. Tell us what tea you like. Last week there was a big love for Irish breakfast tea. Multiple folks actually said they loved Irish breakfast tea. That was the big one. What else was popular?
Somebody mentioned Earl Grey.
Oh, yes.
And somebody was talking about rooibos. I think
I mentioned that. Right. Yeah, my wife's a big drinker of rooibos tea. It's the South African red bush tea.
Yeah, that's also very good. I like it with vanilla. So
yeah, my wife likes it very strong, a little bit of milk. very strong. She'll usually get a big cup. She's got like a massive cup like this big, and she'll sit there and she'll brew it up. You know, get one of those bags you can fill up yourself, whacking the whole of the tea in there, tie up the bag, steep it in there. Massive, great big, literally a bath of tea, and she'll just neck that pint after pint after pint.
We actually talked about this a little bit last time, but one of the cool things, I like to brew my tea really strong as well. So I will use a lot of like loose leaf stuff because that's just what I have. But I brew it with a lot more than you probably would need for like one cup because I drink it throughout the day. The cool thing with tea is it changes over time. As you start steeping it and brewing something, it actually changes. And so the really fun thing with that is if you're brewing it really strong, you can actually kind of get a better picture of that change over time. And it takes less time. So instead of spending like 3 minutes steeping it or something, it can be done really quickly, and then you can just keep reusing it and getting a slightly different taste. And figure out which one of the parts of the steep process is your favorite flavor, because a lot of even like normal tea is going to change. So
yeah, because I used to do that with the dragon pearls. I stick that in a cup and I just constantly top it up, constantly keep topping up with hot water. And you say over time, flavors change. It's nice.
Yeah. Cool.
Cool. So I guess I should talk about what's up on my screen right now for those. So we'll do a quick recap of what we did last week for those who weren't here last week or those who have forgotten, because I don't know about you, but I can't even remember what I have for breakfast today. So I've got no chance to remember what we talked about last week. So this recap is more for my benefit than anyone else's. So the whole thing we're trying to build is a tea tracker. This is what we're trying to build. So Sam loves his tea. We want to make sure that Sam never runs out of tea. And so we're looking at building an IoT device to track how much tea Sam is using. And then we're going to build out a whole supply chain management system. So being engineers, we are going to ridiculously over-engineer this because, why do it the simple way when you can do it the hard way? So we're going to ridiculously over-engineer a supply chain management system to make sure that Sam doesn't run out of tea. I mean, he could just look at his tea as he pours it and just order it, but no, we don't. That's too hard. We want to automate all the things. And this is our IoT device that we're using to do the magic. This is our scales. So we're basing it off scales. The idea being that there'll be a container. I don't have a container to hand, I have Post-it notes that sits on the scales. And then as Sam takes the tea out, over time, the weight will go down. And then from there, we can then order tea. Now, the hardware for this, we looked at this last week. Look at my wiring, my terrible, terrible wiring. There's many better ways you can do this. Sam, you were suggesting copper tape for this, weren't you?
I was. I haven't been able to experiment with it. The first time I tried it, I burnt through all of the adhesive, so it actually didn't stick. So I need to actually figure out how to actually use this stuff, because I was making it up and clearly I made up the wrong thing. But I think that will work. Instead, I've gone back and removed all of the tape from mine. So it's just this giant mess, tangle of wires. Looks very similar to my hair after a day or whatever. That's sort of where I am right now. I'm still experimenting. I recently redid my support thing. I'm still not super satisfied with it. We noticed last session that we were getting some drift on the scales, like the thing was changing. I'm using MDF as my base, and you're using foam. Yeah. And so I think we might be running into some issues with just that deforming and preventing it from functioning as well as we might want it to. So I'm trying to redesign some ways to kind of hold things together so it all works a little bit nicer. But no luck yet. So
yeah, a lot of this is experimentation. We have to try and see. We don't. Have you ever built scales before? I haven't.
No. This is the first time trying it. You have a lot more experience with IoT than I do. And most of my experiences with LED stuff, because LEDs are cool. Yeah. There's LEDs in my background, so and yours.
Good level my LEDs.
Right. LEDs are cool. And so that's sort of where I got started. But then there's just so many cool things. And especially experimenting with like home automation and things like that. That kind of ties into this project. And I've been exploring that a little bit more. And so having those sensors that can actually track something other than a light being on seemed useful. So
yeah. So again, just recap for those who weren't here. So if you actually look at these sensors, see they kind of they sit off, kind of they flex. So this last lovely little white thing flexes. So you've got a separate section in the middle, and then as this metal moves, causes the white thing to flex, and that's what sends the signal. And then you wire these all up together, feed them through to a board, this little board here, and then from there we take that to the Pi. There's 4 connections here to the Pi. 2 of them are power, 5 volts from ground, and then we've got a data line and a clock line, which you need to make sure you connect the correct way round.
yes, we talked a little bit about this, but it will freeze waiting for input if you connect them the wrong way, because you'll never get a clock signal. So it will just sit there waiting and waiting and waiting.
And how do you know this?
Oh, I've done it. So my background is like games and infrastructure stuff. And in there's a delta time. There's a changeover time. It turns out in IoT land that might be data. Apparently you shortened that, and I misinterpreted the signals. So, and in this case, so did my program. So
yeah, two connectors are DT and SCK. So DT is data and SCK is a signal block. So, yes.
See, that makes sense.
Yeah. It makes sense when you know. That's the thing. It's very easy to not know, plug it in, and the whole thing freezes up.
Yeah, that actually is a kind of annoying issue, because like we're connecting over SSH into our Pis. At least I think both of us are. And so we are SSH from our laptops or workstations into our Pi using Visual Studio Code. And then it freezes up your terminal when this happens. You don't get any input, and it doesn't accept the sig kill either. So you actually need to figure out a little bit of Linux fun to make it stop.
Press the kill button, kill the whole terminal, and start again.
Right.
Yes.
Yeah.
So we're running. This is still running on the Raspberry Pi. Where's my camera going? So it's Raspberry Pi 4. It's a fully featured Linux computer. If you've not come across them before, I love them to bits. I love Pis. I've got so many of them sitting behind me. My lights here are powered by Pis. I've got an ad blocker powered by Pis. I've got all manner of Raspberry Pis everywhere. We love Raspberry Pis. Absolutely impossible to get hold of right now. Supply chain management issues. They are absolutely impossible to get hold of. You go to the Pi store and you literally cannot buy one of these for love nor money at the moment, which is a real shame. Fantastic devices. So pre-order one when they're back in stock. Get one. But these are great. It's quad-core processor. This one's got 4 gigs of RAM, 2 4K HDMI ports, Ethernet, USB, GPIO pins to connect all the stuff. Powered over USB-C. Runs Linux. Absolutely fantastic machine. And I connect to it. Sam said SSHing using VSCode. So VSCode has an extension, which is the remote development pack. And that allows you to remotely connect to Windows Subsystem for Linux. If you use that, it allows you to connect to over SSH or into containers. As we zoom everything out, I've got a very small box here. So SSH, containers, or Windows Subsystem for Linux. And you basically connect, and it's as if you were running on that box. So it's like I'm running on my Pi. When I launch terminal, it's terminal on the Pi. When I debug, it's debug on the Pi. And I can install extensions and all that. So that's what we've done.
There is one caveat to that, just because I've explored a little bit a weird way. It requires GCC, I believe, if you're SSHing directly into a Linux machine. If you don't have GCC on the host, it doesn't have the libraries that it needs to work. So I run into this with like an Alpine Linux server. You're running Alpine Linux, it doesn't have the right binaries to do this. So this might not work in that specific case. But if you're using Raspbian, it should be fine. Just something to call out, because I've run into that, and it's annoying because you just flashed your device and now you can't quite connect to it. So
that's good to know.
Yeah.
So I'm using So I can tell you're an old school Raspberry Pi user. So Raspbian was the name for the Raspberry Pi OS back in the day. It's because it's based off Debian, and so it was called Raspbian. Now it's Raspberry Pi OS.
Oh, see, yeah, it's been a while.
Yeah, that's the new name for it. Not that it matters, search it both, find the same thing. So here I am. I'm SSHing into my Pi. We wrote some code to report the weights. If I just run this code, it should give it a few seconds. So I've got a weight of 0. I've got nothing on my scales. There you go, my scales with nothing. And it wobbles around a bit, as air pressure, I guess, as it kind of calibrates the scales a bit. But if I take my big block of Post-it notes and I put it on my scales, there it is. Big block of Post-it notes on my scales. You see the weight goes up. And I've weighed these with some kitchen scales. They're about 262 grams. So it's got it close enough. It's not perfect. What we've built here, it's definitely not, microgram level, totally accurate scales. You wouldn't use these in a chemistry lab, for example. But for what we want to do, it's kind of perfect. Take this off again. And then the weight should kind of drop down. It drops down to 0. So there we go. Now I'm then sending this up to Azure IoT Hub. So again, talked about this last week, but for those who weren't with us last week, IoT Hub is a message broker. So it's a message broker designed for IoT devices. You send messages in, messages can come off the other side to other systems, and it can manage devices and other bits and pieces. And we spent a long time talking about tea last time, didn't we? So we had a bit of a rush at the end to get all this to get all this working. So we should probably take a minute just to talk through this a bit more.
Yeah, I think that makes a lot of sense. Because it doesn't. There isn't that much code there, but I think what is there is kind of the important, critical bits. This is what makes the actual brains of the whole thing work. And so, yeah.
This device code is not. There's not that much in there. Get that out. Not that much in there. First of all, we create our device client, and this creates via a connection string. Now, this is one of the things we looked at last time. When you create an IoT hub, you have to have permission to attach to it. You can't just connect any device to IoT hub. There is security involved. It's an old joke. Don't know if you heard this one, Sam, but the S in IoT stands for security.
I have heard that one.
Yeah, so IoT devices historically haven't been very secure, and if you ever want to scare yourself, just go and search on the internet for IoT hacks and things like that, and you'll probably never ever want to put an IoT device in your house ever again. I'm very cautious whenever you have an IoT device. I always do a good old search around, to find out what the holes in it are, and there's certain types of devices I would never ever have. Because yes, security is not always the best thing with IoT devices. A lot of this is the mindset of the person or the team building it. It's you have to build secure right from day one. And IoT Hub's kind of got that. So when you connect to IoT Hub, it has to be a known authorized device. You can create the devices manually, or there's a device provisioning service that create devices. It's all based off secret keys, or you can use X509 certificates. So there has to be some kind of security there. In this particular case, there is a connection string. And this connection string has got my IoT hub, my device ID, and then a magic key for my device ID. Yes, bad practice. I'm showing a magic key over live stream, but I will be rotating these keys. So, by the time this stream is over, this key will not be there anymore. You can't steal it. But that way, when I connect with this key, we know that it is this device connecting. And as long as no one else gets my key, I'm fine. If someone does get my key, I can just regenerate. So you kind of have this idea of you have two keys. You'd normally have one that you use on your device, and then if you need to change it, you can push and update your device, change the key so it connects to the other key, and so on. But rotate your keys. So this device, we connect with our connection string. We connect. So that's kind of 2 lines of code, and that gives us a connection to the IoT hub. Then in terms of the code we've got for the scales, we use this library. There's a library for the HX711, And the HX711 is this controller board here. So it's a library that knows how to talk to this board via the DT and the SCK lines. And this is calibrated. So these are the pins that we use to connect, pin 5 and pin 6. And then these calibration numbers come from a calibration script. So there's a script you can run that comes with this library. You have zero, nothing on the scales, it gives a 0. You put a weight on there, you get a weight, and that then spits out some numbers. Because these scales, they just send an electrical signal. They don't send a weight, so you've got to kind of interpret that. We then set the unit that we want for it, 0 our scale, and then we've got a while loop that just gets the weight. We do 35 samples, so it measures it 35 times and gets the average. Build up a JSON packet, print it to the console. That's what we're doing down here. And then we send this to our IoT device. And that will then go to Azure IoT Hub. And I demonstrated this before. If I get the script running, if I actually look at the IoT Hub in Azure, you don't get to see much. It's just a message broker, so you don't see any data. But you do see we've got messages coming through, so message counts. Yeah, not much. If I look at the last hour, there you go. We've had some messages, got more messages. We can kind of see graphs of the number of messages going through. And then what I can do from inside Visual Studio Code, we have an Azure IoT Hub extension, and from here I can monitor the endpoint for my device and actually see the messages as they come through. So that's kind of where we got to last week. So, question for you then, Sam. What do you think we are doing wrong here?
What are we doing wrong here? Oh no. Well, so I think there's a few things. I think one, the connection string is hard coded into our app. I think we want to remove that.
Yep.
Is there anything else? You might be looking for something data specific. I think
I am looking for something specific, but yes, no. I will take a moment. Actually, you're totally right about the connection string. Yes, this is terribly bad practice. Do not do what Jim is doing here. Ideally, you should be learning this from some kind of environment variable. There should be no way for somebody who gets onto your device to be able to get this information. Now, what a lot of IoT devices have is actually secure modules on board. So you might, if you've got a Windows machine that supports Windows 11 and Windows Hello, you probably have a secure chip. If you've got anything by Apple, they have their secure enclave, but you get these kind of encryption chips. So you get a chip on the board that stores an encrypted version of some data, and your programs can read it out, but you can't get it. If you get a hold of the board, you can't read that off. And so you want something like that to store this connection string. You want it kind of burnt onto the firmware. Ideally, you don't want it in a way. You don't want to be using necessarily a Raspberry Pi like this in a device, because someone can pull the SD card out and actually find your code and find the connection string. So yes, very good point. We are doing it terribly wrong here. Maybe at some point we can talk at ways that your device can actually connect and download connection strings and things like that. But yes, that is one good thing. What's the other thing we're doing wrong?
Oh no. I think I don't know. See, I don't know if this is wrong, but we're sending a lot of messages.
Yes.
And I think that might be what you're leading into.
How did you know?
Well, we're sending 4 messages a second, which means we're gonna run out of our free tier hub, IoT Hub subscription, and probably spend a bunch of money on a solution that we really don't care about. I like tea, but I don't drink that much, so I don't know if we need that fine of precision. So figuring out how to control when we send updates and how that works would be useful.
Yes, that is exactly what I was leading to. Yeah. So when you set up an IoT Hub, you pay based off the number of messages. This is kind of how a lot of cloud stuff can work. Is just you pay per volume. As you're doing things, you pay per volume. And IoT Hub, you do pay per volume. So if I bring up the pricing for this, check. I'm using the free tier. And the free tier is 8,000 messages a day. So if you think we've got, let's do some maths. 8,000 with 24 hours in a day. So it's 333 messages an hour, which divided by 60, so that's 5.5 messages a minute. So if we do 60 divided by 5.5, we can only send a message every 10 seconds to sit within the free tier. And that's from one device. So, Sam, how many different types of tea do you have?
6 on my desk. So a lot. Yeah.
So if we've got 6 different types of tea, we can only send 1 message a minute to sit within our free tier if we had 6 different scales. Now, obviously, yes, we're just talking about one set of scales for tea, but if you're thinking about this for a commercial rollout, it can get expensive. So a standard tier. Let's see if I actually bring up the pricing window. Azure IoT Hub. Pricing, here we go. So really, there's 2 tiers of IT Hub. There's the basic tier and the standard tier. The standard tier has a free version, which is 8,000 messages a day. I probably use the standard tier because that has lots of useful bits and pieces. The basic one is just you get messages up, standard has messages back down, and a whole lot of device management and other kind of bits and pieces, configuration stuff. So we look at the standard tier. If you want to go for 400,000 messages, that's $25. Now, if we're sending a message every 4 seconds, so 1 every 4 seconds is 15 messages a minute, 60 minutes. So if we're sending 21,000 messages. Am I doing my maths completely wrong? So let's put some brackets in there. 15 times 60 times 24. Yeah, that is right. Okay, we're sending a lot of messages. We're sending one message every 15 seconds, aren't we?
I think that's sort of where we want to be. We're not there yet. We send 4 per second right now. Yeah. Because the chip gives you a sample rate. So it doesn't send. We're not sending every single reading we get off this chip.
Yeah.
We're collecting 15 and taking an average of those, and then saying this is the weight.
Yeah.
Which means there is some latency when you're reading this.
Yeah.
But that's why there's 4 per second, because it's, I think, a 60 hertz chip. And we're taking, at least I'm taking 15 samples. You're taking 35, so yours will be less.
Yeah, and also the time to send the message. There'll be a bit of gap between. It seems it's going about every 3 to 4 seconds. A message is going up. So we've got time because we're obviously waiting for the message to go to the cloud and we get the acknowledgement coming back. So every 3 to 4 seconds. So that's a lot of messages. So.
Oh, sorry. Is the send message call, is that a blocking call? Do you know, or is it async? Does it wait for a response before it continues?
Yes and no. So there's 2 versions of the IoT SDK. There's a synchronous one and an asynchronous one. So,
okay, how do we know which one we're using?
So there's 2. They're basically come from different namespaces. So there's Azure IoT Device AIO, which uses the Python async IO libraries, or there's Azure IoT Device. I'm using the synchronous one now just because it's just kind of simpler code to see now. But yes, you can have an asynchronous one. It does block when you call it, but you can then use the whole asynchronous routine. So what you do is you'd take a wait from here and put it on a queue, and then asynchronously pull it off the queue, and then send it.
Okay.
But obviously, if you're reading it faster than you can send each message, then are you doing the right thing? Because then you can actually look at things called device streams to actually kind of stream data. So rather than have send a message, you can stream data through. But how often do you need that data? And this is kind of the whole big question: is how much data do we actually need, and how often should we be sending it? Because if we were sending 4 times a second, that's a lot of data.
Yeah, and it's not useful data for us. Like we'd be way oversampling. And I guess the only useful thing that would tell us is we would be able on the server side to be able to detect, like, if you pick something up, if we were just sending periodic things. But I don't know if we need it to be periodic. Like if we need to say send a message every 15 minutes or something. We could like detect the actual state and say, is there a delta greater than X? And use that as a way to detect when we need to send something. So yeah, lots of options.
Lots of options. Well, this is the point where an IoT developer's best friend is a data scientist or a business person who understands the data, because there's lots of options as to how much we can do this, and we need to work out what's the best option for what we want to do. But we also don't want to lose data that's important. So a lot of people err on the side of too much data, and then you've got to obviously pay to send the data and then pay to store the data. But some people err on the side of that because they can then run AI models across the data and do analytics on it. So if we're in a factory, for example, we've got a machine that does machine things, and we're monitoring vibration on the machine. And we know that if the vibration goes over a certain amount, there's a fault in the machine. Now, what we could do is just have a simple, if it goes over a certain amount, we send that data. Or you could sample the data every second and then use that data later on to build an AI model to do predictive maintenance. So, you know that, there was slight wobbles. They weren't within our threshold to actually send notification, but this particular wobble pattern always leads to a problem. And therefore we can build a model to detect this. So for something like that, if you've got plans to down the line potentially do things like predictive analytics, it makes sense to capture all the data. But if all we want to know is how much tea is in the tea caddy, is there value in sampling that level of data?
I don't think so. Like I think even our scales are not super precise. You saw the numbers are kind of wobbling a little bit.
Yeah.
And so maybe there's some way we could run something on the server to solve that, but I'm not that sure if that's actually that valuable to like the use case that we're trying to solve, which is detect trends towards zero. And figure out when something is going to run out of stock. That's sort of like the problem that we're trying to solve. If we talk about supply chains, you have some amount of stock of some item, and then you want to restock it and have a new supply of that item before it reaches zero. And so what we're really looking for is when does this line reach zero? When does that happen? And hopefully it's a relatively linear thing. That would make our job a lot easier. And then from there we can sort of do some predictions and figure out how much lead time do we need for this? Does it take 2 weeks for it to arrive? So we need to make sure we order this new thing 2 weeks before it would reach zero, or even give a little bit of padding before that, and maybe 3 weeks ahead. So you have a little bit of leeway in case something doesn't work. So that's sort of I think the problem we're trying to solve. So because we're just trying to figure out that trend line, the exact specifics I don't think matter. And we could probably even get away with like 1 or 2 readings a day per device, and I think we'd still be able to come close to solving this. It might not be as precise, but if we were trying to tune down the messages, I think that would be an option. What I'm curious about, and this might be a question for you, is can we make this dynamic? Can we scale this up for, we have one device, let's sample every minute. And then because IoT Hub can send messages back to the device. So can I have a configurable value that says, I actually want to collect data every minute, or I want to collect data every hour or every 30 minutes or something like that? Could we do something like that?
Yes, we can. Yeah. So I was just drawing a little graph here. This is kind of what we're talking about. Over time, the weight will go down. And so what we need to do is predict this part of it here. That's essentially what we're trying to do, isn't it? We're saying, wrong one. We are saying, I don't know, I got a weird white bit there. Very strange. But we're saying we'll measure, and then we want to predict this bit here, so we can put the order in here. So this point here, this is where we put the order in, so that we don't run out.
Right. And so I mentioned lead time, and that's like the measure of time before something is at the location it needs to be. So this is your shipping time. So maybe that's a day. Or if you're importing it from somewhere, maybe that's a number of weeks. Or if you're running an actual supply chain, maybe that's a year. So figuring out how to actually predict these things ahead of time can be really interesting. And one of the things that I think will be really interesting, I don't think we're going to get a straight line. I think what we're going to see is it's going to vary. And I think there'll even be like variance based on like weather and temperature and like what's my calendar. And that happens normally too. Like if there's a holiday, for example, people are going to come in and buy a bunch of stuff beforehand. So being able to actually say, hey, last year, everything sold out 3 days before this holiday. You might want to place your order a little bit early and get things in so you have the stock to actually supply that. Those are sort of some of the like end result questions I think we're gonna get into with this. So,
I mean, today is Valentine's Day, isn't it? For example, you think about the supply chain of flowers. You know, the supply of roses needs to go up, leading to today, and then the supply of roses will drop over the next few days. So there's all these things to say, all these different things. But also as well, you're saying about the line's going to kind of wobble a bit. One way the line is going to wobble is, here is my jar of tea. You can tell because it's a block of Post-it notes. Here's my jar of tea, and I want to make some tea. So what I'm going to do, I'm going to take the jar off. Here's my jar. I take it off. I open it. I make tea. My weight's now 0. That doesn't mean I've run out of tea, because once I've taken my tea, I put my jar back on. So my jar was, say it was 500 grams. That's just over a pound for Americans. And then I take out, an ounce of tea, or 10 grams of tea, what have you. It'll go from 500 grams to 0 to 490 grams. And the measure we care about is the 500 grams to 490 grams, not the 0, because the line's going to go like that as we lift the jar up and down. So we've got to know what is a measure we don't care about, which is the 0 reading, because that just means the jar's gone.
Yeah, I think you're right, because I think at least for me, the use case is you actually take it off the scale and then put it back on. You don't have like something affixed to it, and then you just like scoop a teaspoon or whatever out and use that. That's not my use case, at least. So maybe we could ignore 0. I think it could be useful though to have that 0, because that could be our trigger, right? Instead of polling and saying every hour send a new data point, instead we could have it be based off of that event. It goes down to 0. That's a substantial change, and then it goes back up. That's another one. So those are 2 events, and we can send that, and then we're only sending messages whenever it changes. One of the downsides I at least I'm thinking of with polling, if we're polling it every hour or something, what happens if during that hour you're making tea? So that hour comes around and you just pulled it off, and now the scale says 0. Do you send 0 or not? I think that might give some misleading information. So we might need some smartness there to detect both cases. Maybe do a little bit of both.
So this is why you need to have somebody who understands the business case working on an IoT project. You don't want to just have developers doing it. You want to have somebody who actually understands what you're trying to achieve. Because otherwise the developer might go, I'll just send a message every 10 seconds. And then suddenly if that 10 seconds overlines to when the jar comes off, you end up ordering tea. So it's really super duper important for IoT developers to be involved with the business side of things. So actually good observations come through actually from a Chris. Wouldn't you have a set time frame? You're not drinking tea the entire day, right? So yes. You could also say, well, I wouldn't need to take a measurement at night, because here's a window. I won't necessarily be drinking tea. Now, if you have smarts that just do the simply, I've taken I've taken this off, goes to 0. Then when it goes back up again, I then send the new weight. That kind of doesn't matter what time of day it is. You don't have to know about that. But for certain other things, yes. Why would you do things at certain times of the day if you kind of know that this is a time of day when things are not going to happen? Why would you even do that? A classic example would be if you're using occupancy sensors inside a meeting room of an office that turns the lights on when there's somebody in there. You could even have those power down at night because there's no one's going to be in the office. Why would you even run the power to run the occupancy sensors? So yes, understanding the time of day, things like that. Yes, very important for a lot of these IoT devices.
Also for just like the general supply chain too. If you think of like a store early in the day versus a store later in the afternoon, everything's been stocked in the morning. So if you're just walking around and saying are things in stock, probably. But then in the afternoon, maybe not so much. So things will change over time, and kind of going back to that, understanding the business case and actually like talking to customers and product managers who understand like why this thing needs to be the way it is, can be really, really helpful. And it's a super fun conversation. So like some of these problems are really fun. Supply chains are cool because it's software. If you're working in the cloud or doing any of that, it's the exact same thing. We just our supply chains are a little bit faster. We work in like nanoseconds and milliseconds, whereas we're talking about days and weeks. Just a different time scale.
Yeah. And Chris as well. Yep. Just to clarify, we're not talking about measuring a cup of tea. So we're not talking about having, a mug of tea on the scales and we use this to track when we've drunk a mug of tea. We're talking more about the jar that contains the tea leaves or the tea pearls. So you'd have in your pantry, you would have a scale, and then you would have a container on the scale that would contain the tea as leaves. And then what you do is you'd be taking the container off, take some of the tea out to brew yourself a cup, and then put your container of tea back on the scales. So it's not in a cup, it's actually in a container of the dried tea that we're using to make each cup. I guess, yeah, there is that confusion of we have tea, and tea can either be the tea leaves or it can be, the tea you're actually drinking. So the term, but yeah, same logic though. Yes, again, if you're trying to think about, do I need to have my coffee refilled? If you had an automated system where when your coffee runs out, the coffee machine automatically switches on. That's the same kind of idea, just in a smaller supply chain cycle. Yes, you have the same thing. When I take my coffee off to drink it, that doesn't mean I need the coffee machine to switch on. I would drink it, then I'll put it back, and it'll be slightly lighter. So you'd always, whenever it comes off, you'd expect the weight to be lower the next time, and that's the thing you'll be tracking. So if you think about if I go back to the little graph I was drawing, the weight would actually be going, drop down 0 each time. So you'd have this kind of drop to 0, back up, drop to 0, back up. And this is the drop to 0. We essentially need to ignore this part of the weight.
I like this idea. Making a never-ending cup of coffee. We should do that. That should be a thing that we do.
You just put the coffee back and then it just fills up. Right.
Wouldn't that be cool? And the cool thing is, I think you'd be able to build that with what we're doing. Yeah. The only thing you need is some sort of pump to do that. Probably one that is safe to use with things you're going to drink. But you could do that. That'd be really cool. So that'd be a fun project to extend what we're kind of talking through here. So if that's something you want to explore or learn more about.
It's that basic idea as well. I've just put a link. There'll be a link appearing in the chat in a minute. So I build a 24-lesson IoT curriculum. And in that, I actually teach digital agriculture. And part of digital agriculture is automated watering. So you have a sensor, a soil moisture sensor, that measures the level of moisture in the soil. And then when that moisture goes too low, what happens is you then turn a pump on and you pump some water in. You then turn the pump off and you leave it and you wait, because the water takes time to kind of soak through the soil. And then after a while, you then remeasure and then re-water if you need it. Same kind of principle. But instead of having a soil moisture sensor, you'd have scales. You'd put smarts in the scales to say only pour when there's a cup there. So check for the weight of the cup. And then you could kind of have that feedback loop of pour a bit of coffee, check the weight, pour a bit of coffee, check the weight. And then, yeah, if the weight is 0, you don't pour any coffee. But exactly same kind of idea. And you can buy little tiny pumps that pump water. I'm guessing coffee would work, but you'd want to really clean those out afterwards. Water for plants, one thing, but if you've got coffee just sitting there inside, you're might need to get a pump you can definitely clean. But yes, in fact, I think you should build this. And then then we should get you on one of these, and you can show us your coffee maker, because I think that'd be an excellent thing to build.
That'd be cool. Yeah,
So
definitely.
cool.
I might have a project to extend this now. So
yes. So the conversations are just talk. All of a sudden, the environment is completely different. The device is both completely different than what's expected. Oh yes, totally. Yes, this is why prototyping is a really important thing to do. You can build your device, you can come up with your ideas. This is what we're going to do, and then you prototype it, and it doesn't work. There's a lovely story about this, which I really like, which just highlights how important diversity is in the workplace. Is somebody built some a smart hand dryer. So most hand dryers, put a hand dryer on the wall and just use like a distance sensor or infrared something to detect something goes underneath, and the hand dryer comes on. Now they wanted to be a bit smarter, so that people put like a bag underneath and it doesn't come on. So it's designed to detect hands. And so they built this thing, put your hands under it, detects your hands, and the hand dryer comes on. The train likes the story. Yay for the train. So you put your hands under it, the hand dryer comes on. But when they actually tried it in the real world, the environment, as you said, was completely different, because in this particular case, black people tried to use it and it didn't work. Basically, it was an entirely white engineering team had done it. They hadn't bothered to actually think about people who didn't have white hands, because there's so many other people who are not white that it didn't actually work. So they didn't actually test it properly. So essentially, they built a racist hand dryer. I can't think of any other way to describe it than a racist hand dryer. So yes, you need to have a very diverse teams building these things that can think about all these possible scenarios, can try a lot of these things out. It's funny, but it's also incredibly sad, the fact that people just aren't building the right kind of teams to think about these, to kind of consider these issues. But yeah, you're totally right. You need to try things out in a real world scenario. The final environment is always very, very different. So yes, we could build this thing. It'd be fantastic. And Sam's got getting his coffee poured instantly every time, and it's great. And then he goes and installs this in, I don't know, the reactor in San Francisco, and everybody ends up with tea all over their shoes because it's not working properly. But yes,
yeah, and a device that sprays boiling liquid has a few considerations I think we need to make as far as like safety and stuff, because that could get unfortunate for anybody using it, if even like the hose slips or cup isn't quite in the same place and you just pour a whole bunch of boiling liquid onto your desk. Probably isn't what you want.
No, I don't know about you, but I got some very expensive equipment on my desk that belongs to Microsoft, and I don't really want to pour coffee all over them.
I think I go through a keyboard like once a year because tea or something ends up on it, because I do things like this, and then I have wires and tea and stuff, and then keyboards don't like that. So
just drinking cups of tea can be so dangerous. Anything else automated, it's asking for trouble. So as Chris also says, I deployed radar motion sensors with solar panels. The producer promised X amount of hours of runtime and then never tried the sensors in a Nordic country. At wintertime, it works for 1 hour. Yeah, again, it's have to think about your environment. If you're just testing anything that's solar powered in a country that gets, or just part of a country gets a lot of sunlight, it's going to work very, very differently. So Sam, in San Francisco, how many hours of sunlight do you get a day?
Ooh,
All of them?
I mean, on a normal day, most of the time it's sunny. Depending, San Francisco's a weird example here because weather changes in like a few blocks. So you can if you walk a mile, you're going to see like 3 different weather patterns, and it's all going to be different. But it is an interesting thing. I think like you'll see people here just always wearing coats or carrying around just like a spare jacket or like long sleeve shirt because it can get cold and just like randomly, even in the middle of summer, it can happen. So if you're ever visiting, I highly recommend like just have like a windbreaker or something because it's near the ocean and there's wind and fog and also lots of sun. So it's interesting.
So I guess fog's an interesting point. If you had something that's solar powered, but you get the fog coming in, that's not going to work so well.
There was one of the apartments I used to live in. They were installing water sensors. So like if your washing machine or your whatever is leaking. Mm-hmm. But the washing machines were installed outside, which is weird. It was a weird design, but they were outside in their own like little cabinet on like balconies and stuff. But there was so much fog in the area that there would literally be condensation on your windows and everything every morning. Mm. And so the water sensors would literally just go off constantly because you had liquid sensors and they were condensing constantly. So you just it didn't actually help that much. So fun IoT stories.
Yeah, but it's true though. You need to think about the locations you're going to be deploying these things because you deploy a moisture sensor like that in a foggy area, and you've got trouble. So yes, all this is really important. Again, it comes down to talking to the business folks, the product folks, and just understanding how you're going to be deploying these things. IoT deployments doesn't always the generic solution doesn't always work for everybody. You kind of need specialist deployments in each area, which is, I guess, why there's a lot of successful companies who do installations and they will actually customize hardware to suit your needs as an organization rather than you just buying an off-the-shelf thing.
There's a really good example from Kelsey Hightower. I think he runs like developer empathy sessions, where you bring in developers and have them use the products that they're building and see how that works, and take notes and be like, hey, this doesn't actually work as well as we thought, or this doesn't do what we think it's supposed to do. You try to rely on it just using like public knowledge, without any like embedded team knowledge that you have just because you built the thing. Just try to use what you're doing without actually doing it, and use your products and see how well it works.
I kind of feel that the people who make a certain well-known smart speaker should probably do that, because I feel that a certain smart speaker could be improved by the people who are responsible actually using the blimmin' thing. Not that my family and I shout very loudly at this particular, mentioning no Long River-based companies, but yes. I'm sure anyone who's got an Alexa is like, "Yep, I know what you mean. I know what you mean." But no, it's true. A lot of these devices we need to try them out, and the end users need to actually. Well, the developers do need to try them in a real world scenario to see what they're really like. Once a developer's got the third load of boiling hot coffee on their lap because they didn't design the automated coffee refiller successfully, then that will hopefully fix some of the issues. You hope.
Right, or in our case, we're like the long-term solution for this would be let's automatically place an order with our tea, right? Mm-hmm. If we didn't solve for this, we would be placing an order for tea every time we made it, because we'd be pulling it off the scale and say there's nothing left, quick, place an order. And I don't have that kind of money to buy tea literally every time I make it. Also, I don't have space for that. So, but yeah, like those kind of things would come up. So I think figuring those out and kind of also having a place to test them is usually a good thing. The cool thing with software is typically failure is free. And so figuring out how to do that initially can be really useful, until you start rolling it out to a bunch of other people. Because you just have software, you can change it really quickly. If our Python code doesn't work, or we would need to change our message, or maybe switch from ounces to grams, or grams to ounces, or change how we want to implement this, we can do that as we learn and kind of figure it out. We have to be doing on that learning path. Otherwise, we're not going to even be aware that these could be potential issues, and then we're just going to like have somebody else take our thing and say, "Hey, look, here's a scale that's constantly publishing an API of how much tea there is. Let's just automatically place orders when it says 0." And then somebody else from some other team sees your API and says, "Okay, we're going to do that." And now you have a problem. Mm-hmm. So yeah.
It's also good to think about when you build a solution, sometimes you don't want to implement the entire solution. So sometimes your MVP, your minimum viable product, should actually solve some problems in wetware. So if you're not come across the term before, software is the code we write, hardware is the devices we build, and wetware is people. Because, if you cut us in half, we're quite wet on the inside. But so you think about if you had the first rollout of an automated supply chain management platform, where prior to this, it'll be somebody getting numbers and manually making orders. What you could do is change how they get the numbers. So they get the numbers from your scales, your automated system. And then because you've got a person involved, if they get a notification say, "We need tea, here's the data," they could then just double check that as part of what they would normally do as part of their standard ordering process. And if it's right, then they'll order tea, and then they can give the feedback to say, "Yes, over the past month, every time it said you needed tea, you've actually needed tea. It has worked. Now we can look at bringing the automated layer." So you actually add that barrier in place, that kind of manual processing for somebody to double check the data before you spend money and put in an order. So that's kind of a good halfway house. You start off, because that gives you time to then build out the ordering system, because you build the device first, get that working, and then the actual API to make a connection to your supplier and actually do the purchasing, you can build that whilst the real person is testing out your hardware. So it's kind of, again, things to think about as you're designing the whole end-to-end product. What should be the right deliverables and when?
Yeah, definitely. I think because especially if you're talking about implementing this, it's expensive. If you actually want to like roll this out and say, "Hey, we're going to just completely change the entire system." First off, you need to develop the entire system. So now you're investing a year or two of actual development time just before you actually have anything done, just so you can like prove the concept out and get the entire thing built, because you're replacing the entire thing. So you don't have any of those old safeguards. All that old stuff needs to be re-implemented again. Whereas if you do it in parts, you can sort of start swapping that out. One of the cool things I've been finding with that, like IoT Hub, is it's event-based. And I'm a huge fan of doing event-based stuff, because I like the actor style of architecture where you send events and subscribe to events, and that's how they communicate. So if you need to react to change in weight, you just subscribe to the change in weight event, and then you can react to that however you want. But the important thing is you're doing that, so you can. Maybe step one is put it into a dashboard, which is sort of the step that we're going to be taking is grab these events, put them into a dashboard. And then what do we do after that? How do we attach programs onto this so that instead of just putting it into some pretty display that we can put on a TV, how do we actually like do something? How do we take that, find patterns, and figure out how to make decisions based off of the data we're actually pulling in?
Yeah. And because it's events, multiple subscribers to those events. I think that's one thing a lot of people don't realize is any kind of message-based system, you can have multiple subscribers to each message.
Right. And so sorry, go ahead. I
was just going to say, so if you want to store the data for later and you want to have it going to your analytics for supply chain management, the same message goes to both. You just keep on tacking on multiple subscribers. And each subscriber can then filter that. So you could say, well, look, this is the T one, and this takes the stream of data coming in, just filters it out for these devices that we know have got T. And then this goes and orders T. And then here's another one that just filters it based off devices. All listen to the same set of messages. And another one says, I'm going to store the whole lot. You can have as many subscribers as you like to each message.
Right. And so one of the things that I really like, the thing that makes like the large scale apps a lot easier when I've been building them with events, is the events serve as a load balancer between things. Because you don't need to build an entire service that can handle the entire load at any point in time, you just need the front bits to be able to accept things and say, hey, process this. And here's all the events. And then you can just pull it in as you're ready. So if you need to process that really fast, you can just scale way up. You can just spin up a whole bunch of functions and just pull all the events in and get it processed. But you might not want to do that. That might be really expensive. You might just want to process these over the next hour. So you get all your events in like 5 seconds. You import like a database or something. And then you can just slowly process them and get them sorted out. And that might be fine for your use case. And so events make that possible. If you're trying to do this with REST and just sending a bunch of requests, whatever service is scaled up the most and is the fastest is going to impact the rest of the system. You're going to need to scale everything else up to handle that load. And so you can kind of avoid that with events. So,
yeah. And one thing I will show you with IoT Hub events. Let me zip around to my IoT Hub. What's cool as well, the way a lot of the event mechanisms inside Azure work is based off what's called consumer groups. So if I take my endpoint, so this is my event hub compatible endpoint. So although it's an IoT Hub, I can access like what's called Event Hub, which is a standard Azure event broker service. And then I have these consumer groups. And so consumer groups each pull data off the hub. So if I'm sending messages, that message goes, one copy of each message goes to every single consumer group. So I can create a consumer group called, I don't know, storage. And that just puts things in storage. I could then create a consumer group called stock order for ordering. And then what I can do is I can actually have multiple instances of my services connected to one consumer group. So if I have, say, 10 stock order processing engines, they could then connect all to the stock order consumer group. And then because they're on the same consumer group, as a message comes in, it'll kind of just get picked up by whichever one is ready. So I won't get any duplication, but I can kind of scale it by having multiple connect to the same consumer group.
That's super cool. Because yeah, you typically you think of it as either one to many, like you publish and then everything gets it, or many to one, where you have a whole bunch of things publishing messages and then one thing gets them. That's neat. I haven't played with this.
Yeah. So because also, I mean, having multiple consumer groups, I got a stock order one and a storage one. My message comes in, the storage one picks it up and stores it. Stock order one picks it up and sends the stock ordering system. So I can the same message can be processed multiple times by different consumer groups, and I know that my consumer group, I can throw as many services as I need. So if I just need to scale up my stock order processing, I just scale that up, and they can all just pull from the same consumer group, and it's just like, it's lovely. And this little thing above the consumer group, this retain for. So this is pretty cool as well, because when an event comes in, your service that processes the event could be down because services go up and down. You're doing a deployment, there's been an outage, you've got a bug in your code and it's broken, whatever. But when you actually read from a consumer group, you can do what's called checkpointing. So you actually store somewhere, this is the last message I processed. And then when you connect back to your consumer group, you say, this is the last message I processed, give me the rest. And so if you're down for half an hour, the messages are still there. They're retained for however long you set. And so you don't lose anything. You would just, you say to the consumer group, yeah, last checkpointed this message here. And it will go, right, since then you've had bang, 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 bang. And you just get those, you just reconnect and all those flood through. So you never lose messages. Obviously, retain for a day. If you're out for longer than a day, you'll lose that. But then you can adjust this. So you can retain for, I can't do it because I'm on the free tier, but you can kind of change how much you retain for. So it's pretty cool.
That's super useful, because I've had similar app issues with that where things would have issues like overnight, but it wasn't like time critical that the service come back up. So if the service crashes at 10 p.m. on a Friday night, it's fine. At least in this use case, it was fine, as long as it came up eventually, before the messages started expiring. which means you don't necessarily need to page somebody and have them spend their weekend solving this, as long as the events can get solved eventually. That isn't always the use case. That isn't always a business case that is supported. But in some cases, if it's a like not time sensitive thing and just needs to happen sometime, this can be a really nice way to actually make sure like it's fine. Our app was down for an hour. Well, we were cool and we just fixed it. And we didn't need to do all of this stuff. We didn't need to like get all hands on deck and just fix this immediately. It lets you kind of architect and fix things a little bit more elegantly than you might otherwise.
Yeah. You still have to page someone on a weekend, but if it's just an overnight thing, then yeah. So it's really nice. It's kind of got this nice little kind of management of all these messages.
Yeah, I'd much rather wake up at 7 and be like, oh, I need to go spin this back up, rather than get paged at 2 a.m. and be like, oh, I'm really tired.
I don't need to do this because it'll be fun to tomorrow. Yeah.
Yeah.
Also, as well, RT Hub's actually got message routing. So you can actually, rather than you manually writing code to kind of pick things off, you can actually route messages around. So if you wanted to route into storage, you could actually add an Azure storage account and it'll automatically route the data into storage for you.
That's cool. I did have a question actually about some of the message sending. That it seems like there were multiple ways to send messages. There was MQTT I was reading and REST. What do you know? What's the difference between those two?
Yeah. So when it comes to kind of the microcontroller endpoint, the microcontrollers, they're very low power. They're designed not to do much quickly, and they need to send messages around. Now, when it comes to actually sending messages, you can either actually have a proper message broker, or you can just make calls to kind of mock everything up. Now, so the way a standard message broker works is you normally have some kind of socket connection open between the two endpoints, and messages will be sent between that socket. So the socket stays open, and then the microcontroller will send a message to the cloud to say, here's a message, or the cloud would send a message to the microcontroller, and the socket stays open, the messages go back and forth. Now, MQTT is a message queuing telemetry transport, I think, but essentially that is a standard message type for IoT devices. So MQTT was invented by IBM, I believe, and then open sourced, and it's a lightweight messaging protocol. It's kind of become the standard for Internet of Things devices. So under the hood, when you spin up, say, the IoT SDK in Python, when you actually spin it up, you can choose to, I wonder if that's actually listed in the documentation. You can choose whether you connect over MQTT or HTTP. And then when you connect over MQTT, there's nothing in the docs here. When you connect over MQTT, under the hood, it uses the standard MQTT protocol for logon, authentication, and then sending messages back and forward. And so each one goes to an MQTT packet, a little bit JSON packaged up, and goes as a message. And so MQTT, it's a full message broker implementation. So messages go back and forward. It doesn't take much power because you kind of got an open socket that send when messages go back and forward. It's kind of quite low power usage. Now, on the other side of the fence, when you have HTTP, that is basically making REST calls. So when you connect over HTTP, your device will make a REST call to say, here's a post. I'm posting you a message. And that's great for unidirectional communication. So when I'm sending a message to the server, I make a REST call, my message goes over. If I want to get a message from the server, because there's no socket open, because there's no message going back and forward, I have to poll. So I would have to make another call, a GET request to the server to say, are there any messages for me? Are there any messages for me? Are there any messages for me? And so if I want to pick up messages even close to real time, I am constantly hitting the server saying, are there any messages? Are there any messages? Are there any messages? And that burns through a lot of power. So whereas MQTT, because the socket's kind of held open, the messages are kind of instant. When they're ready, they'll get pushed to the device, but you're not making that constant poll, so it's a lot lower impact on the battery life. So MQTT, lower impact on battery life, lower impact on data rates. HTTP is just standard REST request, very heavily on data rates. Now, the upside to HTTP is firewalls. If you think about an average corporate firewall, HTTP requests go through the firewall because people need access to the internet. So sending a message over HTTP is fine for most firewalls. MQTT runs on a different port, and that might be blocked.
Okay, that makes sense.
Yeah, so if you need to work with firewalls and you can't open up an MQTT port, you go HTTP. Otherwise, MQTT is the better option.
Okay, but when you're getting started, it sounds like it probably doesn't matter that much until you start scaling way up. Is that fairly accurate, or is there one that we should that you should bias towards if you're making a choice?
I mean, the default. So if I take the Python example, the default is MQTT. So I can connect over HTTP. You can also do MQTT over WebSockets, which is another way to get around the firewall if you want to. But so you can choose to create an HTTP one. The default for it is MQTT. So you probably just want to stick with the default. If you're going down the Arduino route for your microcontroller, you have to explicitly choose. Again, choose MQTT. From your perspective, using the SDKs, it doesn't matter because the API is exactly the same. So unless you get hit by a firewall issue, go to an MQTT route and all the APIs are exactly the same.
So should we explore receiving a message and try to do this? We had talked a little bit about having a configurable polling rate. Should we try to set that up and see how that all works?
Yes, we should. And actually, said about configurable polling rate. Hey, Chris says if you get hit by a firewall issue, remove the firewall, right? Yes. Because as we know, the S in IoT stands for security. So who needs a firewall, you know?
Don't do that.
Don't do that. Yeah, don't do that. So you said about sending messages back and forward. I do want to actually talk a little bit about a couple of the message types that we could send back and forward.
Ooh, okay.
So there's the messages we've been sending to the device. So, the ones we're sending through, the ones that show on our little graph and all that, messages we send through our device are what's called device to cloud messages, also known as D2C messages. And they go from the device to the cloud. Now, those messages, the device sends them, they sit on the cloud. We've got one day to read them back and all that kind of stuff. You can also send a cloud to device message. So if I actually go to my device and choose my device, I can send a message to the device, and I can actually put in, a message, and I can send this to my device. In fact, to handle this message, they've changed the API recently. On the right, let's make sure it's picked the right path and template. Let's bring this up, see if it's going to help me. They've changed the API on this fairly recently. Client, what is it? It's on message received. I'm going to refer to the SDK and to show you an example from the SDK. I'll actually use this synchronous samples, receive a message, just to make sure I get the right format of the handler. So I have a method here that will print out a message. Yes, I know there's no doc string there. I don't care about pylint. So I've got a message handler. It's just a function that takes a message and it just dumps the message out. We've got data and then any custom properties. So this allows us to dump out the message that comes in. And then we just wire it up by saying the on received is this message handler. So if I now rerun this, that started and connected. And then what I can do from here, I can just send this message. And then you should see, there we go. Message received. Hello world, and then custom properties. And I can kind of use this. I send the body here. And then if I wanted to add key value pairs to it, I can. Yeah, property called foo, value of bar, whatever, send that message. And something may be wrong with the dumping out of those properties. They're not appearing right. But yeah, so I can send messages back and forward. And then notice that's pretty instant. I send it and it goes there. Now, the problem comes if my device is offline. How do I get this information? If I turn my device off for a while and then turn it back on again, how do I know what the settings should be? Because, I can send the message, device is offline, don't turn the device on for a few days, I could lose that message. And so I've got to think about how can I ensure I get something. So really these messages that we send, these cloud to device messages, are you really only useful for transient messages where you maybe build, or something where you build some kind of hacking system. So it could be, I would send a message from the device to the cloud to say, send me something, and then the response would come in as a message. So that'd be very much a handshake type situation. Or the cloud would send a message to the device to say, you need to do this, and the device would then kind of handshake that back. So it could be a message to say, you need to update your firmware, and the device will then go down with the firmware, or something like that, where there is that kind of handshaking in. Maybe that if the message doesn't go through, the cloud can know about it and not respond. So, for example, if I kill my process, my device is not running, and I send my message. Oh, why is it saying sent? Should come up and say it can't be sent because the device isn't running. I didn't actually add the property. That's why that wasn't working. But yeah, I think it's not going to pick it up. So if I restart my device, okay, it is picking it up. Okay, they keep changing these things. It used to give you an error if you weren't actually connected. But yeah, these messages are not going to stick around. So we've only got this retain anyway for like a day on our consumer group. So they may not stick around. And it could be when my device starts up, if that message contains something useful that I want, I may have to say to the cloud, send me the device. So it's kind of where it's all a bit kind of transient. This isn't kind of guaranteed data. So what this is kind of leading to, which I'm probably not explaining very well, is we do have another way of sending messages around. And we have what's called a device twin. Now, a device twin is essentially properties that you can assign to a device. And IoT Hub keeps the twin in sync between device and cloud, as long as you've got the code to handle the twin. And so this would be the kind of place you would put configuration information.
Ooh, this is my thing. I'm a big data person, and this is exactly it, because like my thing is always set up data so you can reproduce it. Like with what we're doing, we're just hacking code on our Pi, but we're making tea. What if I pour tea on my Pi and I want to reprovision a new Pi? This seems like a really good way to do that, right? Because I can take the twin and just say, make this.
Yes. So this wouldn't be, for example, where you put the weights. So when we've got like the weights, I've got my thing and I'm measuring a weight, that would come as telemetry, because that's something that we just care about what the current value is. But when it's something that needs to be persisted, this is the place to put that. And so we have desired and reported. So the desired is what I send to what I want the device to have. And the reported is the actual state of the device. And I can get this on the cloud side, I can get this on the device side. So if I just go to the sample code and grab the twin sample, receive twin, I'll just copy and paste this code in. Same kind of idea. We have a handler function to handle the twin, and everything's sent as patches. So you don't get that. This is the whole lot. You can just send a patch and say, this is what's changed in my twin. And then I just set up a handler. So it's one line of code set up the handler, and that handles this function here. So if I now kill this and relaunch it, and I then go back to my code here, I can go in here and say, well, you know what? My desired, I'm going to add a field on here called
let's do like reference unit and 0 value, because those are the two things that we need to configure for each device, right? So this might be, at least from my uninformed position, this seems like a great use case for this, where we can actually store this in the cloud and then we can configure it and persist it and see what it is and transfer it back.
Yeah. Reference unit and offset. So I actually got my numbers on the wrong way. Reference unit is -26. Yeah, we can store this in the cloud. So if I put this in here and then save that, what should happen? There you go. So you see, this is the patch, reference unit 26, offset. So it just sent us the patch, just sent us what's changed and a version number. And then you'll see here, now that it's refreshed and desired, reference unit offset, and then we've got the last updated version, and then the value when each value was last updated. So we kind of got an audit trail, a little bit of an audit trail kind of built in here, which is pretty cool. Now, when we first, so if I kill this and relaunch it, we won't get, unless they've changed things again. Yeah, that happened. Cool. So we're not getting this patch. So at the moment I've only wired up when it's changed, but the standard behavior for your code is once you've connected, the first thing you would do would be to actually get the twin.
Okay, can you feed that back into your same handler, or does it do other things? So could we?
Yeah, so get twin. Ooh, I've just noticed a problem in the code here. So the get twin supposedly returns none, but according to the docs, it returns the twin as a dictionary. Ooh, let's explore. Let's see what actually happens. Right, so actually, if maybe it could be PyLancer's picked up this hasn't explicitly specified a return type. So it could be PyLancer's picked up the none. I don't know, but there we go. So when we're pumping it straight back into the same function, and so you can see here we get a little bit more information this time. We get when it was the patch, it just sends what changes. This actually sends the whole thing, so we get the whole desired block.
Okay, it looks like maybe I missed it, but it looked like the schema changed too, because the last time I just saw it come with the reference number and offset, and not the desired nested bit.
So when you call get twin, it returns the whole twin, the whole lot.
Right.
When you get a change, you just get the patch. So you actually see this method called this property that we're setting is on twin desired properties patch received. So that's designed to just pick up a patch. There is no way of getting the whole twin. It only ever sends a patch. So it only sends the delta. So if I go in here, for example, and I change my reference unit to -27, save that, what should come through in the patch when it's saved? You see, it's just the reference unit, the offset, and the version, not the whole thing. So it does mean in your patch handler, you've got to put the smarts to handle both, or when you get it, you handle it with code that just pulls out the reference unit, the values you want. But this is there. This is now there permanently. So if I turn off my device and my device is switched off for a month, and I then power my device back on again, bang, it loads the latest one. So my server-side code could update this as many times as I like with my device being offline. It doesn't matter, but when my device connects, it pulls all this data down again.
How does this work if the device is offline but still operating? So if the device is still processing things or restarted but doesn't connect back, does it still pull in is the initial or current version of whatever the state is saved on the device so it can be restored? Or
you'd have to build that logic yourself to persist that information.
Okay, that makes sense.
Because the thing is, this code just connects to the hub. It doesn't know how you want to save anything. So what you would do is if you want, ideally IoT devices should be able to run offline unless it doesn't make any sense for them to run offline. So for something like this, you would want it to persist the twin locally somehow. And then when it starts back up, if it can't connect, it would then use the twin it's got that's stored locally, and then also package up the data. And then when it does connect, it will read download the twin and send all the messages.
Okay, that makes sense to me. Means you have to kind of manage that, but that's cool. For us, I think we're just gonna reboot the device. I think that makes sense. I don't think we want or need to do the patch, because for us, we need to run a specific program to zero this. So really what we're doing is we're just moving the data. We're moving it from something that we hard code into the app into something where we can run the same code on every device, but zero each device individually. I think that's sort of the value that I see here. And then we can just grab our stuff. And that twin patch or get twin is a blocking call. So you could just do this in your initialization and get your entire config and then set everything up from there.
Yeah. Or if I use the async version of this, then again, that'll be an async call, but I need to make sure that completes before I do everything that relies on the data.
Right. I don't, yeah. For us, I think we can ignore the async stuff.
Yeah.
Yeah. Cool.
So just going to take a couple of questions. As Chris asked, doesn't that depend on the severity of the message? MQTT, you can specify the device should verify the message received, and the MQTT will try until the device verifies. Yes. So MQTT does have a whole load of configuration you can set on the messages, whether you want the message to be lost. You've got basically fire and forget. It's send and then wait for an ACK, or then keep sending till it gets an ACK. There's a number of different variants of it that you can choose with a message when you send it. If I'm sending one from here, I don't know how much I can configure what the setting is, but yeah, sometimes you can set the with MQTT, you can kind of set it to keep retrying. Now, one thing I will say is under the hood, IoT Hub does not use MQTT. It uses the MQTT protocol to talk to it. Internally in IoT Hub, it uses its own stuff. But the MQTT or HTTP is just the interface you use to connect. So this isn't an MQTT broker. I don't have the same configuration on IoT Hub that I would have on an MQTT broker. So with MQTT, you configure a lot of things around authentication and message retries and things like that. IoT Hub doesn't have that configuration because under the hood is not MQTT. That's just the interface you use to connect. But in terms of the interface, it is real MQTT. You can connect to it using an MQTT library. And you can literally roll your own communication with IoT Hub over MQTT. But once it hits IoT Hub, the hub itself is not a full MQTT broker. So just want to make that. But yeah, great point as Chris, but I just want to clarify that. It's not an MQTT broker. So you don't get the same types of control because MQTT brokers, for example, can run insecure. You can run it, allow anyone to connect. This one you can't. Yeah, we do not let you do that. Because that is the very bad thing. So yeah. But also as Chris asks, how is the integration of the IoT service towards other Azure services? Are they super seamless, sending to web functions, DB containers, etc.? Oh yes, it is seamless. Yes, that's a great thing about cloud providers is a lot of the infrastructure is built on the same concepts. So if I want to take a message from a device and do something with it, I don't have to build using completely different technology than if I had to build using messages from somewhere else. So for example, if I want to wire up events I want to handle an event subscription. So I want to take a message off my IoT Hub and do something with it. I can connect it to Logic Apps, Azure Functions, Web Hubs, Storage Queues, Event Hubs, Hybrid Connections, Service Bus Queues, Service Bus Topics. These are kind of the standard components of an Azure application, and IoT Hub speaks those languages. So, I can build a Logic app that connects to Azure IoT Hub, and there is a connector for Logic Apps for doing this. So Azure Event Grid is kind of the tooling that a lot of services can use to share events. IoT Hub supports Event Grid for managing this kind of stuff. but also it's got the Event Hub compatible endpoint, the one with the different consumer groups we talked about earlier. So anything that can connect to Event Hub can connect here. So if I want to spin up an Azure function, I can create an Azure function that connects to an Event Hub. I connect it here, and then I can write my Azure function code to do stuff. And that function can then save my data, do what I like. I can use this as an endpoint into Stream Analytics. So Stream Analytics is an Azure tool that's designed to take streaming data and process it. And this can be an input query. I literally say, my input is this IoT hub, and I just write my query against it. Or I can do things like message routing. This is all built in. So I can say, let's add a route, and I can add this to an endpoint, and my endpoint can be storage. In fact, should we do that? Should we save this data into storage just because we can?
Yeah, sure. That sounds actually useful, because we need it to end up in storage, right? Because we're trying to do some fancy dashboards or something to analyze this, which means I think we can't just store it in events. The downside of events is they're really hard to like get any like larger queries and ask like what is this data saying, because you're just pulling one thing at a time. So database means we can actually grab it and do things with the data we're collecting.
Yeah. If the saying is just because we can, you always do it. Yes.
Yeah.
We do it because we can. So I will admit, I've never actually used this routing. I've done a lot of it manually. So this is going to be a voyage of discovery for me as well. It should be a bit of fun. So I'll go back to where I started from. Under IoT Hub, we have this message routing. And this is where you can route messages to endpoints. And up to 100 routes for each IoT Hub. And it's all based off a query. So if I create a route here, I will call this route, let's call it store data. And then I add an endpoint. And for that, I want storage. Now I'll call this one store data storage. I can't do underscores for this one. And I need to pick a container for it to go in. I'll create a new storage account. IoT. Can't have. We'll create this in West US 2. So that's going to create a storage account. And this is just like a standard Azure storage. This is a generic storage bucket, and I can use it for queues, blobs, files, tables, kind of whatever I want to store in there. So this is now creating my storage account, spinning it up.
That was cool. I sorry, that was super cool. Just like doing that, and it's just working. Because I mostly when I'm working from like a CLI or some configuration language.
Mm-hmm.
So this is super cool to me. Yeah.
Right. So this is my storage account. So I mean, I love the portal because I just can't remember all the different CLI parameters and what have you and commands. This is obvious in front of me. It's like, I want to add this. Oh, I need to add this. Click. It's very well designed in that if I need to connect A to B, but B doesn't exist yet, I can create a B automatically. I just go through and create the B, and that becomes what A is for. So I don't have a storage account. I'm creating one. I don't have so I need a new container for it. We'll call this one weights. Let's create this. That's my container. Right, this is my container. So I'll select this as my container. So that's my container. And then I can choose my frequency. So rather than have it written every single message, I can have a blob of it. So this is, this is set to every 100 seconds. So every 100 seconds, it will write. Every 100 seconds, it will write. And then you also choose sizing as well. So when it actually writes a blob, it won't be one blob per event. It'll be a blob of a certain size. So I end up with multiple blobs containing multiple messages. But you know what? Let's drop my batch frequency down. Let's drop it down to every 60 seconds. Yeah. Then I could choose my encoding. So Avro format is a much more condensed format. I'll go for JSON because it's a bit more readable. And I can choose the name of it because it saves it as JSON files. So I'll create this. This will create my storage endpoint. It's nice this. I want this thing. I don't have it. I create the next thing. To do that, I need this. So I create the next thing. And just click, click, click. Now, for a production deployment, we would build scripts to do this. We'd manage it through whatever, but for prototyping, click, create, click, click, click. Absolutely fine.
This is how I learned C#, actually. Because my C# is almost entirely like self-taught, and it was literally just opening up Visual Studio and going, what does this button do? Oh, that creates an entity framework thing, or this spins up this new like WPF example and things like that. And going through these wizards is how I learned. And especially if you have, I think a key here is having some budget constraints or something on this. But if you have a storage account, or if you have a subscription with storage accounts, or you're using like the free student subscription or something that caps it so you can't go over, clicking these buttons is less scary because then you can actually start tinkering with this thing, and you'll have those limits to kind of prevent you from provisioning a bunch of stuff and then forgetting about it until the end of the month. So
now, the downside of that is if you have like a student subscription, you get $100 worth of credit with your student subscription. And then when that runs out, that's it. You've got none left. So if you do spin something up and you leave it to the end of the month and you burn through $100, you then can't do anything. You kind of run out. So it's good to think a little bit about pricing. Whenever you spin something up, have a look at the pricing just to get an idea and work out when you need to spin it down again. Something I will say is important to track that. Things like storage accounts. You pay for basically the amount of data you use, and the average human who's doing prototyping is never going to do anything that's going to really cost anything. It might be a few cents here and there because you're not bombarding it. We use the free tier of IT Hub. There's no cost for that, and the 8,000 message limit going into a storage account. You're not going to fill your storage account. It's not going to be expensive. Your $100 of student data or your $200 of your Azure free account is barely going to be touched by this.
Right, I would also recommend just create your own resource group when you're setting a new project. Create a resource group. Don't have everything in one, because if you delete the resource group, it will get rid of everything inside of that resource group. So that's a really quick way to just clean up after a project. If you're just finding things out and have like a weekend that you just want to like hack, at the end of the weekend on Sunday night or whatever, just delete the resource group and it will all get cleaned up.
Mm-hmm. So. Yes, always put each project in its own resource group, and then you can delete it projects as a whole. Yes, because if you put everything in one resource group, then you end up forgetting one thing and think it's for different projects. Chris says that's one of the best perks of Azure, to be honest, the resource groups. They're so useful, so simple yet so useful. So I've had the root, I've created my storage, created my endpoint. I can choose what data goes into my storage. This is what's quite nice as well. It's not just telemetry. I can do lifecycle events, so devices connected, devices it's being provisioned, connection, disconnection events, twin changes, device twins and digital twins. So digital twins are kind of cloud versions of IoT devices. We're outside the scope of all this, but device twins are the ones we saw where you're sending the twin back and forth. So I can actually store all those different things. One kind of analytics, if I'm doing a commercial rollout of 1 million devices and I want to actually see, track when the devices connect for the first time, I can just put the connection information in here. So it's kind of nice. I can kind of route different ways, different data, different ways. Enable, disable, and then a routing query. So this is quite cool. You can actually write a query on your data. So it could just be, I want telemetry, but only from a device where the device name starts with T.
That's super cool.
Or I could say, only do it if the weight is more than 10 grams. So I could actually add filtering here.
Right. So we could do like all of the filtering we were talking about of being smart about like filtering out small scale changes or something here. That might be a little bit excessive for what this seems like it's for. But that could be, that seems cool. I'm going to need to tinker with this. We don't need this now though, do we?
No, we'll just have a query of true that says send everything through. And Chris says it's super cool until you create a device that does not start with T and you debug for days. Yes, you forget you got this query on there, and we're suddenly we're wondering why we're not seeing a certain device and someone's named it coffee or something instead of tea. Yeah.
One thing that might be useful for finding those is from Azure, you can actually export your resources as their Azure Resource Manager configuration files. And I imagine this would show up there. So you'd be able to find these queries and all this other configuration that you have for these services in there.
Mm-hmm.
That's also a really useful way for like recreating your infrastructure, but it's really cool as a way to like analyze your infrastructure and see like, are we using these queries? Are things properly like resource managed and things like that? Because you just get a data format, and as long as you can parse your, I think it's JSON, then you can just go and do whatever you need to do that. And then if you change one thing, you'll actually be like, you'll have a git diff of how the resource changed.
Yeah.
So yeah.
So let's click save on this, and that should save and spin up the root. So give that a second to save. Make sure we're running. Let me reset, because I zeroed it at the start, and when I restarted, I had my weight on there, and so it was. You'll notice the weight was -225 when I took it off, because I zeroed it with a weight on it. So let me start it up and zero it with a weight off. So let's give them some correct data. There we go. Now I'll put my weight back on. There, that takes a bit there. So this is still saving. Yeah, things do take time in the cloud. It's got to allocate resources, make connections, and all that. But essentially, what we'll see when that saves, if I go back here, this is the storage account I created. If I go to my containers, this is my weights container, and eventually we'll start to see data appearing in here. So, oh, yeah, this is done. It's now created. Now, when I set this up, I had the 60-second batch on my, where are we, on my endpoint. If I go to my endpoint, we set it up with a 60-second batch. So we're not going to see any data. Yeah, this one here, batch frequency 60 seconds. So we're not going to get any data until we've been at least 60 seconds. So we'll give this a bit of time, and eventually we'll start to see data appear in there once it's had time to run. But it's that, I don't want to say simple, because it's not simple. You have to know what you're doing, but it's designed with this level of connectivity in mind, that if you want to wire up the output from one thing to another, all the pieces are there. As long as you know what the pieces are to do it, all the bits are there. So if I want to add any kind of message routing to other systems, it's all there. It's going back to that actual question of how is the integration of the IT service or other services? Are they super seamless? Yes, they are super. It's very much designed to be this level of seamless. Let's say one of the Stream Analytics or Azure Functions on here, I spin up an Azure function and I say, here's my endpoint, and my function just runs. It's great. I love it. It's obviously taking a bit of time for it to actually get going. Sometimes it takes a bit of while for things to kick in. The very first time when you start things up, it can take a while. Yep, so it's healthy. Cool. So hopefully, there we go. IT reactor stream 1/22/02/14. So block 1, 2022, February 14th at 19. So this would have gone at, I'm in Pacific time and we are 11:44. So 11:43, this is showing local time. 19 obviously is UTC. So it goes in UTC, 42.json. And if I actually, not snapshot, if I go edit, sorry, here we go. So this is my data. And you see we've got the enqueue time. So this is the time actually enqueued. UTC, set on the end, it's a Zulu time, 1942. No properties that came with message. The system properties. So we've got my device ID, Jim Scales. My how I connected using a SAS token. I've got generation ID. I have no idea what that is. Another message queue time, and then I have my body, and that body is, that's not very useful.
What is that? Because that doesn't look like a hash or something.
That could be encoded using
Like base 64 or something?
Yeah, that's going to be binary. That's going to be encoded as bytes. So that's probably base 64. So we can find a little base 64 decoder. Let's have a look. There we go. Yep, base 64. So that's my weight, 268.
Okay, so it's exactly like Kubernetes secrets then. It's base 64 encoded and not super secret.
There was a very famous question, I think it's on Stack Overflow, where somebody asked about encryption and somebody suggested they use base 64 encryption and it got upvoted. I don't know whether it's people just trolling or what, but it's like the standard answer on Stack Overflow for encryption was base 64 encryption. And you read all the rest of the answers no! Yeah, I wonder if they've deleted that one.
There's a lot of that with like rot 13 or whatever, where you just move it 13 characters up. Not actually that super secure.
It was
don't roll your own
years ago. Classic Caesar cipher from 2,000 years ago. They were great. Fuel Snable says, "What? Base 64 isn't secure."
I gotta go. Oh no.
Yep, I think you might want to go and audit some of your code. Do a quick grep for base 64, and then yeah. So that's all encoders, binary data. Because things, although I'm sending JSON's text, I can send binary data. So I can send the data in whatever format I want from my device. So I can send binary data. So which makes sense, the basics for encoding. But yeah, I mean that's my. Let's see if we got any more that appeared. There we go. We got more appearing. So a lot more on this one here, because again, it's every 42 minutes past, 43 minutes past, 44 minutes past, 45 minutes past. So it's every 60 seconds it's being written. And there's all my data. And I didn't write any code. So you notice, apart from my device code, I've not written any code at all on the cloud side, and all my data is being stored for me, which is pretty sweet. It's all just done through configuration.
Right. I think we're at like 50 lines of code or something. You might have a little bit more because I think we're slightly different, but like 50 lines of code, and it's commented and we're sending data from a device up into the cloud and getting it written into a database. And all the cloud stuff, it is configuration stuff. It's not actually encoded at all. Like the cool thing with that is you can have some business people go and tinker around with it and kind of figure out how to use some of this stuff and figure out how to manage some of this and actually do that. I found that's actually fascinating. If you get somebody who's just worked on like the product of a data or like the output of a system, and you actually show them like, here are some of the things that we get, and here's how some of this works, and here's how this can be accessed and analyzed. There's some really interesting conversations that happen from that. So
yeah, because you could very quickly knock up some dashboards on this, or just something to see the data, and people can see it, they can discuss it and work out, like spotting, go back to the idea of the graph. We're going to drop down to 0 at certain points. Just by having this data there that somebody can look at, they'll go, oh, why is that weight 0? Starts those conversations about what we do with everything.
Yeah, I think that's sort of where we're headed too. The goal is now to get this into a time series database, I think. We're using time series insights, I believe. I think that was one of the ones we wanted to try. We had a few. We were talking about Prometheus and time series insights as like two options of things to do. I use Prometheus in my own stuff because I like grabbing some of the open source stuff and building my stack like that. But time series insights gives you a little bit more. So we're considering looking at both of those and kind of playing with that and building some dashboards and actually seeing how we can actually take this data and actually make it actionable, so we can actually figure out how to actually answer these questions.
Yeah, because I mean, the whole in terms of which one we use, going back to Chris's question of how integrated all these systems, time series insights is completely integrated. So we would better spin this up again with no code, click, click, done, and we've got data going in. So Prometheus will probably have to write some codes to take it from somewhere, put it into Prometheus. But it might not be much code. It might just be a very small, an Azure function, a few lines of code to say insert into here.
Yeah, I think there's a lot of different ways. Yeah, I don't know exactly how much we need from Prometheus, or if we can just like maybe set up Grafana dashboards, or even go crazier and do some other things. I think there's a lot we can do with this, but we'll see what kind of information we get out of this, like time series insights. Because I think like the thing with programming is there's always there's lots of options and ways to solve any specific problem, and there isn't one right answer. It's not a quiz. So you can kind of pick things that you're comfortable with or you like, or that you just want to learn more about as sort of ways to do that. So that might be driving this decision, I think.
Yeah, and it's whenever you pick technology, there is always a lot of decision to be made as to which one you use, and sometimes it's what are the needs of the business. Is our need time? Do we have to get it done now? If so, what's the quickest thing we can use? Is the needs of the business very specific that we want to do a certain thing that a certain tool solves? Sometimes the needs of the business might be, how do we keep our developers happy? Developers are a very in-demand commodity. And so tech companies that give developers the opportunity to experiment with technologies that they enjoy can lead to happy developers. So maybe the right tool to use is the one that the developers want to play with, because if you've got happy developers, they're going to be a lot more productive. Forcing developers to use a tool they don't like is a good way to get developers to consider other opportunities.
And it can hurt your retention too. It can be hard to keep people working on a tool they don't like working on.
Yes.
So
Fuel Snable says our front-end devs have started to refuse fixing bugs. And as front-end devs are hard to find, yes, it is a problem. You getting that right balance between we are delivering the things we need to deliver, plus we are considering the productivity of our developers and how happy they are. It's a balance. Now is the best time to get into technology, apart from every other minute before now. The best time was 20 years ago. The second best time is now. Because there is this huge demand for people, and that does allow us to be a bit picky potentially about the projects that we pick to work on. So developers should be involved in those discussions around what tools are going to be used, because they may have interest in areas, or they may have experience in areas. If it could be that a developer was at a conference, watched a great session on Prometheus, and come back and say, no, although time series insights, click, connect it, Prometheus is better because I've seen this thing that looks really good and I've learned about this and I want to do it.
Right. I think, there's all sorts of different things. I think the thing I would encourage is just experiment and explore, especially with containers. It got a lot easier to do that, because a lot of this stuff you can spin up locally or in a really restrained environment that doesn't require like going and provisioning a full new server and spending all of these times like figuring out budgets and stuff. You can just go and do this on a Friday, and try this out and be like, hey, I was doing this, let's go do that. I would just say, if this is like a culture that you're trying to build, have some way to show value for it. Like have some way to actually show like, hey, this is the thing that I built. Here's how it works. Here's how this works. And here's why I think it's cool, rather than just like going off and doing something, because then it's not visible to anybody else. And that gets a little bit harder to sell. I've run into that issue myself.
Yeah, some teams, if they're doing like 2-week sprints, for example, may have a 2-week spike sprint where you literally play with something, and the agreement is at the end of the spike, you'll come back and you show what you've played with. Here's what I've done, here's the upside, here's the downside, this is why we should consider it. So actually having that time-boxed period to do this investigation and then have a defined way of explaining your results is kind of needed. It's not just I went away for 2 weeks to play and that's it.
And also, when you're estimating time, like build in some of those experimentation periods into your estimate for time. Don't like oh yeah, we can write this in 8 hours. So let's do 4 sessions about building IoT. Let's like get some time just so we can actually explore what are good options for this. Why does it make sense to do it this way? And why would that be cool rather than maybe this other option that seems just as good? So yeah.
Yeah, let's just say the containers make things easier, but also just if you've got a predefined service inside the cloud, if I wanted to spin up time series insights, click, it spun up in seconds. If I want to spin up a container, click, it spun up. I don't need to spend 3 days, 4 days configuring something, trying to get servers purchased and, all those kind of painful bits and pieces. I can spin it up in such a short space of time that the effort level just drops drastically. If going back pre-cloud days, if I wanted to test out a particular service, I could try and install it locally. That could break other things I've got installed locally. If I had to get a server allocated, it can take months sometimes to get a server available to you just to test something out. But I can spin this up in an afternoon, test it out and spin it back down again. So it gives so much more flexibility for trying things out.
When you don't have to go through like expenses and things if you're doing this, you don't have to spend that entire month like having these meetings with your manager and saying, hey, I want to try this. Here's how much it's going to cost. Here's how much time it's going to take. You can just go and spend the 2 hours instead of spending the 20 or whatever in the meetings organizing it. Because I've definitely done that, and I'm so much happier when I can just go and experiment and explore it. So yeah, that's one of the things I like about cloud.
Yeah, well, so we used to think of Microsoft Night the Tour, and that was our whole, all around the world, a whole of sessions on Azure, basically a free conference. And I was giving some of the Azure fundamental sessions, talking about virtual machines and how easy they are to spin up. And whenever I did that, I'd always recount a story from a friend of mine from Hong Kong. I've spent 3.5 years living in Hong Kong, and a friend of mine worked for a large bank, and he needed a Linux machine. So he built this product and then he needed actually a machine to deploy this product to. And so he had to do the paperwork, he had to submit what he needed, then they would come back with options, then he had to choose the options, and then so much back and forth in the whole thing to actually get the machine provisioned. And so the time it took from when him saying to his manager, I need this Linux machine to roll out something to production, to when he actually got the credentials to log into the machine was 6 months. And I would tell this story on stage whilst I'm spinning up a virtual machine, and I would get the whole virtual machine spun up, ready to go within like 3 minutes. And it's just, doing something, go pre-cloud, doing this kind of stuff was just pain. That 6 months, he was in meetings almost every week, planning meetings and all this, just trying to get this machine. And I'm there on stage in front of 1,500 people in London going, click, click, click. Oh, look, I've got my virtual machine ready. And it was the same state that his was in, which is now it's ready to, it's just got Linux on it. That's it. So yes, it's the speed we've got with these tools is just phenomenal.
Yeah, I'm a big fan. We should probably wrap it up. We have 2 minutes left. So I think our next session is we're looking at time series and trying to get this data into it. I think that sort of makes sense as where we're going. We've got it configured. We might need to do a little bit of tweaking to actually pull some of the configuration in and use that. But I think we've kind of got to the point where we can communicate back and forth. And our data side seems good. I think we just need time series, and we need to configure how often we're going to track this information.
Yes.
Those are the two like open questions. So if chat has any suggestions on how we should solve that, maybe things we should look at, this would be a good time to like call that out, or maybe ping us on Twitter or something. Let us know like what do you want to see, or if you're working on this, let us know as well, because seeing other things get created is also very, very cool. So
yes, please, if you're doing stuff like this, share it with us. But yeah, as I say, we're getting time series insights, and we can actually look for the data coming through and use that to help us design when we send it. So should be fun next time. I'm very excited, looking forward to it.
Awesome.
Cool. Well, thank you, everyone. And yeah.
Well, thank you so much, Jim and Sam. I appreciate it. It was a really great session. And everyone else, I also want to thank you so much for joining. And please, if you have a couple of minutes, I'm going to put the link for the feedback also in the chat. Please use the event code 15298. If you have a couple of minutes, we'd love to hear back from you. And thank you so much, and have a good one.
Cool. Thank you, everyone.